Welcome to ScienceCover.com. In this session we look at pressure and temperature. We'll focus on Brownian motion and how pressure and temperature are related. First, pause the video and try the Do Now task. Check your answers to the Do Now task. Let's begin by looking at Brownian motion. Robert Brown was born in Montrose, Scotland on the 21st of December 1773. As a botanist, he used a microscope to study plants. In 1827, when studying pollen grains floating on the surface of water, Brown noticed that the pollen moved in a random, unpredictable, jittery motion. Robert Brown's initial assumption was that the pollen was alive, but he repeated the experiments with inorganic materials and he saw the same effects. Brown and scientists of the era could not explain why this effect happened, but they named the random jittery motion of tiny particles after Robert Brown. It was known as Brownian motion. In 1905, Albert Einstein wrote a paper proposing the reason behind Brownian motion. Einstein suggested that the pollen particles, despite being small, were clearly large enough to see with a microscope, but that the millions of moving water molecules are too small to see even with a microscope. As the tiny water molecules move, they bump into the pollen, and this causes it to move slightly. This causes the observed jittery motion. Pause the video and complete task 1. Let's check our answers to task 1. What is the name of the scientist who discovered Brownian motion? Robert Brown. What was he studying at the time of his discovery? Pollen grains suspended on the surface of water under the microscope. What did he observe in his experiment? Random, unpredictable motion or jittering from the pollen grains. What was his incorrect initial assumption? That the pollen grains were alive. Why did Einstein suggest that we see Brownian motion? He said the pollen molecules were large compared to the water molecules, so we could see the pollen with a microscope, but we could not see the water molecules with a microscope. The water molecules are moving and strike the pollen grain, causing the pollen to move. Now let us look at the relationship between pressure and temperature. Any change we make to the temperature of a liquid or gas will affect the pressure of the liquid or gas. If we add heat to the liquid or gas, then the particles gain more kinetic energy. This means that they move around faster, and therefore they strike surfaces or each other with more force, and they will strike each other more often. This increases the pressure from the gas on the container walls. Now, any answer that we want to give to describe how pressure and temperature are going to be related, we should mention heat, we should mention the kinetic energy, we should mention the speed of the particles and how that relates to the force of their impacts. We should bring in the frequency of the collisions, and we should relate that to pressure. Let's look at an example of this in action. Explain why heating water in a sealed container can cause an explosion. The first thing we want to mention here is that heat in the water is going to add kinetic energy. We then want to link the idea of kinetic energy to the speed of the particles. If the particles are moving faster, it means that the force of impacts is going to be stronger and also more frequent. We can then link this idea to the increase in pressure in the container. And finally, if the pressure of the container is increasing, then there's going to be a point where the pressure becomes too much for the container to withstand. So as our answer, we've said that as the container is heated, the particles gain kinetic energy. This means the particles move faster, they collide with the walls of the container with more force and more frequently. This increases the pressure of the container, and too high a pressure can cause the container to burst. Now, this answer contains all of the key science that we need in our answer. We've mentioned heat and energy, the speed of the particles, the force of the particles, and how that relates to pressure. Example 2. Explain why an egg will explode if heated in a microwave oven. Now, this answer should follow a similar pattern to the last. As the egg is heated, the particles inside gain kinetic energy. We then link the idea of energy to the movement speed. So this means that the particles move faster. We then want to link the idea of the speed to the force of the impacts from the particles. So they collide with the eggshell with more force and more frequently. We then link that to the pressure. So we're increasing the pressure on the shell. And eventually we state that too high a pressure will cause the eggshell to crack. So again, our answer includes all of the main science that we should include in this type of answer. We've mentioned that heat and the kinetic energy. We've mentioned that the particles are moving faster. We've mentioned that that increases the force and the frequency of the collisions. We've mentioned that it increases the pressure on the shell. And we've mentioned that this will eventually cause the shell to crack. If we look for a pattern as to how pressure and temperature are related, we find that they have a linear relationship as long as the volume of the container in which they're in is kept the same. Now, if we use a temperature scale where absolute zero, that's minus 273 degrees Celsius, is the start of the scale, so let's call that 0 Kelvin, then the pressure is directly proportional to the temperature. And that means that if we double the temperature, so if we go from 10 Kelvin to 20 Kelvin, the pressure will double. Now this means that for a fixed volume, increasing the temperature will increase the pressure. But the situation also works in reverse. So increasing the pressure will increase the temperature. If we blow air into this inflatable shark, then we are adding particles that are moving with kinetic energy. And this increases the overall kinetic energy inside the shark, which means that the temperature of the shark goes up. Pause the video and attempt task 2. Let's check our answers to task 2. Describe the relationship between temperature and pressure. Pressure is directly proportional to absolute temperature. As the pressure increases, the temperature will increase. Explain why an aerosol can has a warning telling the user to keep it away from the flames. Heat from the flames can cause the pressure inside the can to rise. This could cause an explosion. Explain how a flame can cause the danger mentioned in part A. So the heat from the flames is absorbed by the particles and they gain kinetic energy. The particles move faster. They strike the canister walls with more force and more frequently. This raises the pressure inside the container. Eventually the pressure is large enough and the canister will rupture. Question 3. Hot water is stored inside a tank and then allowed to cool. Explain what will happen to the pressure in the tank and why. As the water cools, the particles lose their kinetic energy. This means that they move slower. The collisions with the walls of the tank become less frequent and less forceful. This lowers the pressure inside the tank. How will adding air to a flat football affect the temperature of the ball? Adding air will increase the temperature of the ball. Why? An increase in the pressure with a fixed volume results in an increase in temperature. Increasing the amount of air means there are more particles moving inside the ball. This increases the kinetic energy inside the ball, increasing the frequency and force of collisions between particles and the ball, and results in a raising the temperature of the ball.